So in this video, we're going to talk about what a gauge factor is, specifically for a strain gauge. So all gauge factors is it's a number that's given by the manufacturer that relates the change in resistance to the change in strain. Okay, so what we can basically say here is the gauge factor is the ratio of the change in resistance that we're measuring on a strain gauge relative to the axial strain. So for metallic strain gauges, the typical value for a gauge factor is about 2. All right, so for a strain gauge, the one thing that should be given is that a strain gauge typically has a primary axis where we're interested in measuring the strain in. All right. So typically the strain we'd be interested in measuring for a strain gauge would be along the axis where you see all the different gauges going. All right. Now this. All right. Now, if you have an applied strain that goes in the opposite direction to the strain gauge, right, you could get something that's called you could get some lateral sensitivity. So basically, this is strain that would be measured along the direction that we're interested in. All right, but it would be due to strain in a direction that's not being directly applied. All right, so we can quantify this error if we know a few different things within our system. Okay, so it helps to know if we know what the actual axial strain is, what the lateral strain is. All right, what is the Poisson's ratio of the strain gauge the material was calibrated at. All right, and what is the lateral sensitivity of our strain gauge KT. All right, so all right, so the definitions are all written here, and then the last thing here we know is this KT value. In order to determine the KT value, we can use this chart down here. So if we know the ratio of all right, if we know the ratio, all right, of EL, all right, and EA, and we know the lateral sensitivity value, so that's given by the manufacturer typically. You can then typically determine how sensitive the value would be, all right, or the error would be. So so if you look it all up here, all right, you can look up on the x-axis. You can look up the chart on the ratio of the linear and the axial strain, and you can see how much percentage of error you'd expect in your axial strain due to that. Okay. Now you can then use this error to then compensate the value for your own for the original values to get the true lateral strain and the true axial strain.